हाँ बोलो।
The first one was just related to the email that I received from you this morning regarding the final and the class start date. And I just didn't really understand what you meant by Monday. Is it like both of them start Monday or
I
just
haven't sent out any email.
I just received one from you this morning?
No,
You-
I
Okay,
don't know
so
who
I
sent
had
that.
sent you an email yesterday right after class
Yeah,
saying that I
no,
realized,
on Monday is going to be your final. That's it.
okay.
Yeah. And after that, you can go home.
Okay, so then is the new class that was supposed to start Monday pushed back to like Tuesday, or
Yeah,
are they
yeah,
gonna let us
yeah.
know? Okay. Okay. Um, my second question is if you don't mind just clarifying for me the lesser and greater momentum one more time because when I was trying to review it today, I just found it a little bit confusing.
Okay, listen, dear. Now, what the lesser and greater momentum is, there should be no question about it. This is mainly okay, just peritoneum. Okay. Now, first of all, if we say it's okay, yes, this is the liver. Clear? Okay. Now, okay. And if we say that okay, this here is your stomach. Did that make sense? Okay. Now, what we will have is that there's going to be peritoneum that comes from the liver. Clear? Okay. Pretty much okay. Yes. Okay. And go on to the stomach like this. Did that make sense? Okay.
Mhm.
Then this very peritoneum here is okay is going to continue on. Now, at the greater curvature of the stomach, instead of just okay making a direct U-turn and go on to the back of the stomach, meaning it's okay to cover the posterior end of the stomach or backside of the posterior side of the stomach. What the peritoneum is going to do is going to just okay continue down like this. Clear? Okay.
Yes.
That makes sense.
Yes.
Good. Okay. And here, this is me that's okay going to be hanging between, yes, okay, your anterior abdominal wall and okay, has other structures in the abdomen, like okay, you will have the large intestine, you have loops of the small intestine, etc., etc. Now, ultimately, what this peritoneum here is going to do is okay, it will make its turn back. Now, please, that's okay. When I say peritoneum, is going to include both parietal and visceral peritoneum. Okay, and then yes, okay, it goes back like this. Okay, and now run at the back side of the stomach. Okay, then from the lesser momentum, it runs back onto the liver. Okay, and then it's okay from the back side of the liver, it's okay onto the anterior surface of the posterior abdominal wall. Did that make sense? Okay, now what do we call this? is going to be the lesser momentum. Okay. And what do we call this? It's the greater momentum. Did that make sense?
Yes, it did. Thank you.
Okay. Okay. Now, whether you look on the greater momentum or whether you look at the lesser momentum, we can say, okay, that's going to be as okay. But we here says, okay, was an anterior layer. Okay, and that was going to be as okay, posterior layer. Right, okay. But this anterior layer here is okay. What is that going to be made of? It's going to be made of both parietal peritoneum and visceral peritoneum. Likewise, it's okay. The posterior layer is also going to be made of a parietal peritoneum and visceral peritoneum. So if you look at it, we can say, okay, parietal peritoneum, and then visceral peritoneum, because these layers of the peritoneum here is going to be as okay. In this case, we can say, okay, this was the, for instance, okay, we will see we had the liver up here, right? Okay. Down here, so okay, would be, let's say, the stomach. Okay, stomach. So this will be the layers of the peritoneum from both sides, anteriorly and posteriorly will be the visceral peritoneum, and out that is going to be the parietal. Okay. But this whole structure here is going to be what we call the momentum. Okay, okay. But mainly as okay, we call it lesser momentum because okay, that's the momentum that runs between your right is okay, the liver and the stomach. But the same arrangement is going to be down here. Okay. So at the front or anteriorly, we have it's okay, the layers of peritoneum, mainly it's okay, it's going to continue. And what are they going to be made up of? They are still going to be made up of what's okay, parietal peritoneum and visceral peritoneum. When it goes, and okay, it makes a huge back there. Yes, okay. What do we have? Again, still parietal peritoneum and visceral peritoneum. Okay. And here's okay. We said okay, yes. We had the stomach. Did that make sense? So this mainly is okay because so this is going to be okay another layer of momentum, but we call this one the greater momentum. And the chi that I said was that this curvature of your stomach here is the greater curvature. Okay. Whereas this curvature of your stomach here is okay was the lesser curvature. So at the lesser curvature, lesser momentum, greater curvature, greater momentum. Okay. Now, guys, please make sure that you remember that this is the greater curvature of the stomach. And this is going to be the lesser curvature of the stomach. That's going to come, it's okay, very helpful once we start talking about the blood vessels. Okay? Any other questions? Or Asma, did that answer your questions?
It did. That was helpful.
Okay.
Thank you.
No problem.
I have a question.
Go ahead, Vicky.
So in my notes, under the nasal passage, I have it says secretes up to 500 milliliters or a pint of mucus in 24 hours, but I don't have what it is. Like in the book, it said mucus membrane, and it also says like richly vascularized. But is it the mucus membrane or is it the nasal passage itself? Like what?
No, the mucus, listen, my dear, when they say mucus membrane,
Yeah.
that's just going to be as okay, the lining. Okay, okay. Did that make sense? Okay. Because membrane, what is that going to be as okay? Mainly as okay, is just a lining structure. That's why it says okay, cell membrane. What was that? That outer outline of the cell. Okay. The reason that they call it a mucous membrane is because it secretes mucus. That's the only reason why. They refer to it as the mucous membrane.
So that would be the answer. If you said secretes up to 500 milliliters or a pint of mucus in 24 hours, it would be the mucous membrane. That would be the answer.
In the nasal passage.
It would be mucous membrane in the nasal passage.
Yes.
And it's richly vascularized.
It's richly vascularized. Okay.
Okay.
What does it mean to be richly vascularized? That it has a lot of blood vessels.
Okay. Thank you.
Okay. Well, the whole point of it being richly vascularized is blood flow. Okay. And what that blood flow is going to just okay produces, well, okay, I won't say heat, but yes, okay, it's going to just okay, you can say okay, provide the tissue with warmth, and that's going to just okay warm up the air that you inhale in. Okay, to bring it close enough to the body temperature. Did that make sense? Okay.
I have one question.
Yes.
The ligament falciform
Yes.
in the liver. So how would you be able to explain how those peritoneum layers like form that ligament?
Okay, it's pretty much similar to yes, okay, what we said about the momentum. Okay. Now, okay, guys. Again, so yes, okay, if you say the oh shit. Sometimes I will do this. So my dear, if you set the liver, okay. Now just so you know what the blue we are talking about, we can say okay, that we are looking at a side view of the liver. Okay. And we can say that we have the anterior abdominal wall. Yeah, okay. Now on the anterior abdominal wall, what is it that we're going to have? The peritoneum will be running. Okay, so the peritoneum is okay. That'll be running up against, that's okay, the anterior, yes, okay, the inside of your abdominal wall. Okay, but it was not meant to just line the inside of your abdominal wall, but mainly as okay, also just okay, cover up most of the structures in your abdomen. Did that make sense? Okay, and that's going to be as okay, that once okay, as this peritoneum is okay, as it runs on the inside of the abdominal wall, comes from the right side, and okay, as it comes from the left side, on the inside of the abdominal wall. Okay. And when they meet at some point, what is that they're going to do? That's okay. They're going to turn. Okay. So that's okay from the left side. It's going to turn towards the liver. And likewise from the left, right side. Did that make sense?
So if the peritoneum turns inwards, how does it get down to the stomach to form the lesser omentum?
Because, okay, it runs here and it runs here. Clear? Okay. Now it's going to be running up against the liver. Okay. And from the liver, it's going to just, okay, go on to the stomach. Okay. But pretty much, okay, that's where the peritoneum comes from the anterior abdominal wall and turns on to the liver from the right side and from the left side. What we have is from the right side, and it's okay, peritoneum coming from the left side and turning on to the liver. And this structure is okay, is what we call the ligament falciform. Did that make sense? Once it has run on, it's okay, along the surface of the liver, it's going to go on to the next structure, which in this case is going to be your stomach.
Okay, thank you. And then just another thing, so the pancreas, I know you said it's retroperitoneal,
Yes.
and so the peritoneum is not going to be covering the back of the pancreas at all?
Exactly. Only you're going to be running in front of it.
Okay.
Okay. Okay. So it's only going to be running in front of it, and that mainly causes, okay, as you can say that the pancreas would be as okay lie behind the peritoneum, which we just call as okay, just we say that makes it retroperitoneal. Did that make sense?
Yes.
Okay. Anybody else?
Oh, sorry, I was just thinking about it because the body of the pancreas is behind the stomach,
That's
then
fine. That's
the
fine.
peritoneum doesn't go on it because it's behind
Okay.
it.
Listen, my dear. If this say your stomach, well, okay, you have, and let's just say this is your pancreas.
Mhm.
We already said that, okay, yes, peritoneum is okay from between liver and stomach. Lesser omentum goes here. Greater omentum comes up, goes like this.
Oh, okay.
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 And then it goes on to the liver. So this became, yes, okay, your greater omentum. This is the lesser omentum. But all this is okay, this is your pancreas. So your pancreas, it's only going to be the anterior surface of the pancreas that is okay, have some relation to the peritoneum. Okay. Well, okay, all the other structures we saw is okay. The stomach isn't completely as okay covered, both from front and back. So is the liver going to be completely covered up from front and back. So is most of your large intestine going to be okay, completely encircled in peritoneum. All of the loops of your small intestine are going to be completely covered up. So if you take it's okay, a loop of your small intestine is going to be completely covered up with peritoneum. Did that make sense?
Yes.
Anything else? Okay, guys. I guess we can now go on to chapter number 16. Which is mainly going to be about the urinary system. Okay. And pretty much, okay, just like you were integumentary system, this is well, okay, it is a small system with, you can say it's okay, limited what do we call that fellow? That's okay, numbers of structures. Okay, so anatomically, it's okay, what is going to make up your urinary system? Is going to be as okay, your kidneys. Okay, and we can mean it as okay, we have 2 kidneys. That's probably a little bit strong kidney. Sorry, I can draw that better. A left kidney and a right kidney. Okay. From each kidney, is there going to be as okay, a tube. And that's going to be as okay, what we call, one is going to be a ureter. Now, since we have 2, there's going to be ureters. And just so we know, that's okay, what the blue we are talking about. Yes, okay, this is right, and this is left. So you have a right kidney and a left kidney. You have a right ureter and a left ureter from each kidney. Next thing will be, we have, okay, yes, a urinary bladder. And there's only going to be one. And from that, is going to be, yes, okay, the last passage, which is the urethra. Yeah, okay. So all this here makes up your urinary system. So it's okay, a pretty small system. Okay. Now, before going into the detailed anatomy and so on, for some of these structures here, let's just briefly talk about what are the major functions. Now, major function is mainly going to, we can say excretion of waste. Or more likely we can say here is what we mean by the waste is mainly going to be metabolic waste. And that's pretty much why we use the word excretion. Clear? Okay. In the digestive system, we mean as said that as removal of substances which were not absorbed was going to be elimination. But when we say excretion, that's going to be excretion of waste, which is going to be metabolic waste. Okay. Now, the major part of as this metabolic waste is going to be what we call nitrogenous waste. Which mainly is related to we can say the breakdown of proteins. Or derived from breakdown of proteins. Or amino acids and or nucleic acids. Now mainly as two major products all depend upon as which kind of protein that we get. One substance, Singa. Is going to be ammonia. Okay. Now its chemical formula is NH4. And here is you can see why it is nitrogenous. Even as if you look at the name here, ammonia. Related to or clinging with amino acids. Is that clear? Another, which is going to be a nitrogenous waste from breakdown or other kind of proteins is going to be urea. Okay, as I said, mainly as a breakdown product derived from proteins or amino acids. Okay, which should be as excreted in the urine. Clear? Okay. There are going to be other metabolic wastes. For instance, as we talked about yesterday, from drugs, medications that you take. Okay. Now you might have taken, let's say, 2 tablets of Tylenol. Clear? Okay. Okay. Which is 500 milligrams each. So that gives you as 1 gram of Tylenol. Some of that Tylenol is going to be as lost in the process of metabolism. So let's just say it's okay, 200 milligrams is lost. You are left with 800. Okay. How is that lost? As a result of metabolism. So that needs to be excreted on the body. You can even say, okay, once that Tylenol goes and does its job, because it's going to just okay perform as okay, take part in some chemical actions of the body. At the other end, it's going to end up as a waste product that your body doesn't need anymore. So there's got to be a mechanism by which you'll be able to get rid of that as well. That's going to be via excretion. Did that make sense? Okay, so drugs as well. Okay. Any questions? Now the question mainly is going to be is okay, how? Well, okay, yes, these metabolic waste products here is okay. They are going to mainly is okay be, we can say it's okay, mix with water. Okay, so we can mainly say the cocktail of okay, yes, the metabolic waste and water mainly as okay becomes what we call urine. Okay. Now the question may arise, where does this water come from? This water is mainly as okay taken from the water in the plasma. So some of the water that we have in the plasma is going to become as okay an integrated part of the urine. Okay, so ideally that's okay, whatever we excrete of water in the urine is going to be replaced by fresh water that is being absorbed from the gut. Okay, how did it end up in our gut? That's okay, from what we drink. Okay. Now, just to talk a bit about ammonia. Have anybody ever wondered why does urine smell the way it does normally? Is due to ammonia. So ammonia, that's okay. Not only is it a waste product, well, okay, your body wants to get rid of it. But yes, okay, also give yes, okay, the urine, yes, okay, it's yes, okay, that characteristic smell. Okay. Now normally, yes, okay, you're not going to be smelling it. But if you walk into, yes, okay, an animal cage in the zoo, that smell that yes, okay, hits you as you step in, and that's okay, yes, pretty strong ammonia. Okay, so you say, okay, my pee doesn't smell like that, but yes, okay, that's just okay, the extreme. Okay. Now, why do we need to, yes, okay, excrete metabolic waste? This was all a matter of, okay, yes, maintaining the homeostasis. Clear? Okay. Because, okay, if your body is, okay, keep on accumulating or holding on, yes, okay, that metabolic waste, what's going to happen? Well, okay, those are actually going to end up as acting as toxins in your body. Okay, so pretty much, okay, as by eliminating them or excreting them, sorry, by the urinary system, that's how, yes, okay, your body is able to, yes, okay, maintain the homeostasis. Now, what it also does, the urinary system is not all about, yes, okay, only metabolism, okay, excreting metabolic waste. But we can also say, okay, as a great portion of your urine is made out of water. Okay. So not just okay to replace, you can, let's not say old water, but it's okay. Water is mainly it's okay, is going to okay be excreted. Mainly it's okay just to be replaced by new water. That we mean is okay, just most likely it's okay drink. Okay. But mainly it's okay, enabling it's okay your body to maintain okay what we can call is okay the volume of blood. Okay, the volume of blood primarily. Because this volume of blood here is okay, mainly is going to be vital, or to maintain that in a normal range is going to be vital in this okay regulating the blood pressure. Yeah, okay. So you don't want yes, okay, the volume of water to increase, because that's going to yes, okay, only increase yes, okay, the blood volume. And that may yes, okay, may lead to a high blood pressure. Or on the other end, you don't want to yes, okay, get dehydrated. Okay, because there's not a balance between yes, okay, the water in your body and okay, the water that you may excrete. Okay, because that's going to yes, okay, reduce the blood volume. That reduce of blood volume, that's okay, due to yes, okay, eliminating too much water. That's what you mean, that's okay, called dehydration. Okay, but yes, okay, but that can lead yes, okay, to a low blood volume. That means yes, okay, well, or that you may end up with a low blood pressure. Did you guys get that? Okay. Now, guys, it's not going to be always and always that okay, as when you are dehydrated, or it's okay, I'm going, yes, okay, through dehydration, that the blood pressure is going to all of a sudden fall. Okay, because okay, besides as okay, this is okay, what your kidneys also have is okay, as it produces hormone that's okay, that is called renin. The word ren here is okay, is pretty much obvious that okay, as you can okay, it has something to do with the kidneys. Okay. As a matter of fact, yes, okay, there is a cycle of okay, yes, that we call the renin aldosterone, which means it's okay, are just two different hormones. This aldosterone is mainly okay going to be produced by the adrenal gland. But what these two hormones mainly is okay, they walk on hand in hand. What they is okay mainly will help your kidneys to do is to prime is okay, reduce the amount of water that's going to be okay excreted by your kidneys, or increase the amount of water that's going to be excreted by your kidneys. Primarily just make sure that as we maintain that blood volume that causes the blood pressure to remain stabilized. But in that way, also regulate ensure that as you don't get overhydrated or dehydrated. Did that make sense?
Yes.
Now just think of a hot summer day. Let's put it this way. Think of a hot summer day. Okay. Now what is that you're going to be doing on a hot summer day? Sweating. Did that make sense? Clear? Okay. Now, let's say that, yes, because what happens when you sweat? Well, as your body is going to lose some fluid in the form of sweat. Clear? Okay. You will become dehydrated relatively. Okay. If you don't consume a lot of water. But let's just say you don't have access to water or whatsoever, or whatever reason is that you don't consume water. That's up to you. What you will find is when you go and pee, that you will see my pee is darker than usual. And why is that? Mainly because this renin aldosterone system here said, the water volume in the blood or in the plasma is already lower. So it mainly wants you to retain as much fluid as possible. And mainly reduces the amount of fluid that is going to become a part of the urine. Okay. And that's why the urine may appear darker in color. Whereas, summer or not, you drink a lot of water. Well, you don't sweat. Okay. And what do you see? That the urine is going to be more clear because a lot of that water that you drink, that's me, is going to be you can say a water overload on your body. And then your body may say, we don't need all this water here. This is too much good is bad. So that's an easy way to you can say flush that extra water out is through the kidneys in form of urine. Did you guys get that? Okay. But by doing so, not only does it keep, you can say the blood or fluid volume of your body within the normal limits or the normal range, but at the other end, also helps your body to maintain a normal blood pressure or keep you just well enough hydrated. Okay. But if you keep on throwing up and it's a hot sweaty day and you don't replace that fluid that you lost in sweat and it's dehydrated, throwing up, so and so, you may not. That's that's probably not going to be enough fluid for your body to. That's produce enough urine. Now, last but not the least, and I have probably as okay mentioned this fellow here as okay quite a few times, is erythropoietin, which we mainly as okay said, well, okay, this is a hormone produced by the kidneys. And what do? It stimulates the bone marrow. Clear, okay, mainly to, how we can say it's okay, stem cells in the bone marrow to go on and produce red blood cells. Which means okay that is okay, more and more red okay stem cells need to take the path of hematopoiesis that's going to okay make the red blood cells. Okay, and that's one thing that we find in patients with okay kidney failure. That not only are they not able to okay produce enough urine, okay, to excrete all these metabolic waste products, which may okay just as being hoarded in the house and the body. Okay, because the body is not able to get rid of them, so they may okay go to a greater or lesser extent is okay accumulate in the body. But at another end, as a part of renal failure, yes, okay, there may be a reduced or no production of erythropoietin, which may mean that, okay, yes, your bone marrow doesn't get that signal, doesn't get that stimulus that tells it, yes, okay, produce red blood cells. So as a result of that, yes, okay, a lot of people with kidney failure, yes, okay, become severely anemic. Because the hemolysis is going on like, okay, nothing happened. Okay. A red blood cell that was produced, well, okay, is going to live its time. Get hemolyzed. But since that's okay, we don't have that signal that's going to register that, okay, the blood is running low on red blood cells. I mean, that's okay. It's going to tell the stem cells and the bone marrow, okay, well, listen, guys, you need to, okay, go and, okay, produce red blood cells. So when the loss of red blood cells is greater than the production of red blood cells, so what happens? You're going to become deficient in the red blood cells, and that's what you can call is okay, a form of anemia. Or that eventually is okay is going to lead to anemia. Not to talk about yes, okay, that because it's okay ratio between plasma and cells. Where we all know that okay, yes, 99% plus of the cells were red blood cells. And where we also know that okay, yes, some 90% plus minus of the plasma was water. Now in kidney failures, what do you have? Well, okay, the kidneys fail, they're not going to be able to just okay eliminate the waste products But those waste products are going to just be eliminated in the water. So there's going to be a volume overload. And where it's on the other end is it's that the cells decrease in number mainly because of no erythropoietin or a low production of erythropoietin, which causes that there's no formation of new blood cells. So you have the ratio between plasma and cells is going to go bananas. We normally said that this was 55% of the blood volume. This was 45. Right. But the water concentration or the plasma volume is just going to further increase. Where due to a decreased production or a complete cessation of the production of blood cells or primarily red blood cells, the cell wall as a percentage is going to fall. So this may go to yes, we can say let's go extreme, let's say 75 and 30. Or 80 and 20. Did you guys get that? So yes, people with kidney failure is yes, will be told, well, listen guys, or listen dear, this is the max amount of fluid that you can consume in 24 hours. Okay, this is going to be the max amount of fluid that you can consume in 24 hours. Because the rest of that is just going to be become an overload or a fluid overload on your system.
So would that mean people with kidney failure can have high blood pressure because of the fluid?
You can put it that way. Anything or any of these functions here. Okay. On the other hand, you may say, well, how would the body register that? Yes, on normal cases, how would the body register that you are on the brim of dehydration? Or yes, are running low on fluids. You feel thirst. Clear, okay? You feel thirst. Or you feel thirsty. And that's just your body signal. Okay, listen, guy, or listen, dear. You're running low on fluid. Go, and it's okay. And that's our inbuilt instinct. Then we feel thirsty, as we know, it's probably as time to go and get something to drink. Did you guys get that? Okay. It also is because it's regulates, it's that acid-base balance of your blood and keep it at that neutral pH. Because if there are substances or waste products in the blood that's going to cause the pH to increase, then the blood is no more neutral, it's going to be alkaline. An extreme stage of that can be what they call alkalosis. So that's no good. On the other hand, yes, okay, the pH of the blood falls too much due to, yes, okay, acidic contents in the blood. Then that can lead to, yes, okay, what you call acidosis. Okay. One of the common form of acidosis is what you call ketoacidosis. Okay. Something that we mainly see in people with uncontrolled diabetes mellitus, that their blood sugar levels are too high. Okay. Well, that's pretty much okay going to lead to what we call ketoacidosis. Okay. There's going to be a reason why is okay, because okay, that glucose is not going to be, or it's going to be broken down in the absence of oxygen and produce what we call ketone bodies, which then are released into the bloodstream and okay, as causes what we call ketoacidosis. Okay, so generally speaking, guys, yes, okay, these were, yes, okay, the major functions of your urinary system. So primarily, yes, okay, excretion of metabolic waste. Okay, most of this metabolic waste is going to be nitrogenous waste. But it's okay, even waste product from, yes, okay, breakdown of drugs or medications and so on. So, okay. Your body as a whole, yes, okay, is a big chemical factory. Okay, so a lot of this, okay, chemical activities goes on. That's going to be, okay, a lot of end waste products at the end of, okay, as any chemical reaction. We need to get out of the body. And that's going to primarily be, as okay, via the urine. But generally speaking, it's okay, we can say what is that makes up urine? It's going to be water and metabolic waste. Okay, okay. And we can say, okay, getting rid of that metabolic waste is going to be as okay by the process called excretion. Did that make sense? Elimination was for substances which were not absorbed in the body. So if they're not absorbed, yes, okay, they could not be metabolized. Okay. Why were they not absorbed? Because they were not digested. Did that make sense? Hey, guys. Yes, Vicky, you wanted to say anything there?
No, I was just fixing my computer.
Okay, no problem. Good. Okay, guys. Now, if we look at the urinary system, all we can say is, okay, the organs of the urinary system. So what did we have? And let's use this one here. we had 2 kidneys. Okay. And what we mainly can say is that the kidneys are going to be, well, okay, they are going to be the organ in which the urine is, let's say it's okay, produced or made. Let's say it's okay, made. Where, okay, the remaining structures where whether there was the ureters, mainly as okay, just going to, we can say, okay, transport or carry the urine that already was made in the kidneys. Okay, okay. So that urine was going to be transported or transport the urine. It's okay from the kidneys to the urinary bladder, which was okay as our next structure. And we only have one urinary bladder. And what was the function of the urinary bladder? Pretty much okay, just like the function of the gallbladder was for bile. To, that's okay, store the urine. Okay, just to excrete it. That says okay, at a suitable time. And that's going to happen through the urethra, which means okay, that's going to be okay, the final passage structure or the urine. Okay. So had it not been for the urinary bladder, well, okay, the kidneys would continuously be producing urine. That continuously will be flowing down through the urethras. Just assume that I just considered we didn't have a urinary bladder. That urine will directly go into the urethra, and we will continuously be peeing. So in all this is dropwise. Okay, more fluid or is urine is just accumulate in the bladder onto the bladder is now I've filled up enough, and that's when you feel the pressure. And as that pressure says, it's probably time to look for a restroom or ask for a restroom break. And go and pass the urine. Okay. So these are going to be the functions that we will talk a bit about for the rest of the class. Now, guys, just take a short 10 minutes break. And when we come back, it's okay, we will start talking about the kidney, the main organ or structure of our urinary system. Okay, so see you guys at 10:25.
I have one question.
Okay.
So when we were talking about the renin, because that basically like regulates it regulates your water intake in and out, correct?
Mhm.
So does that also regulate your blood pressure?
Indirectly, yes.
Okay. Thank you.
Not well, okay. We can say in the way that okay, it's going to be as okay that your kidneys will sense that the plasma volume is low. Okay. And as a result of that, yes, okay, that's why that whole circle, yes, okay, gets initiated. Okay. Did that make sense?
Yes, that does.
Okay.
Thanks.
No problem. Okay, guys. Now let's get on to the first main organ of the urinary system. Pretty much okay as the main one, which is the kidney. Or we can say it's okay, the kidneys. Now, one thing that you guys need to realize that okay, as the kidneys, both of them, yes, okay, they are going to be retroperitoneal. Yeah, okay. Did that make sense? Now, guys, if you look at the kidney, it doesn't really matter which one. We can mainly say, and please keep in mind that this is going to be as okay, the normal measurement. This is going to be the length. And that's anything between, yes, okay, 4 to 5 inches. So if you measure the kidney from here to here, that's going to be anything between 4 to 5 inches. So that will be as okay what they call the length of the kidney. The next dimension of the kidney is going to be this. Which remain as okay, we'll call width. And that's going to be between 2 to 3 inches. Yeah, okay. And if you place the kidney in, it's okay, look at like this. Then this dimension here is okay, that's going to be the thickness. And that normally is 1 inch. Okay, so these are, yes, okay, the normal measurements of a normal kidney. So its length, which is from top to bottom, is 4 to 5 inches. the width which is going to okay be from one side of the kidney to the other side of the kidney is going to be normally okay choose the 3 inches, and its thickness which is going to be okay from front to back is going to be 1 inch. Did you guys get that? Okay, and as I already said, okay, that this is going to be retroperitoneal. So if you look at a kidney, okay, it's going to be behind the peritoneum, which means that it's only going to be the anterior surface of the kidney, which is going to be okay, be in some contact with peritoneum, but it's not going to be that your kidney is not going to be okay encircled all around by peritoneum. Did you guys get that? Okay. Now, guys, if, or for instance, okay, if we okay, open up a kidney, okay, we can mainly say that okay, the kidney as an organ okay is going to be arranged in 2 layers. Okay, there's going to be okay this outer layer of the kidney. That we'll call the cortex. Now, since this is the cortex of the kidney, we can say it's okay, that's going to be okay, the renal cortex. But the cortex that's going to be okay, the outer layer of your kidney is going to be referred to as the renal cortex. Whereas inner part of the kidney is going to be called the medulla. Now here, since we talk about the medulla of the kidney, is okay, we can say it's okay, the renal medulla. Did you guys get that? Okay, so the outer layers of the kidney is going to be referred to as the renal cortex. The inner is going to be the medulla. Now, students, we actually just okay find this similar arrangement of cortex and medulla in 3 other structures. This is not only found in the kidney. This arrangement is also found in the brain. The French says okay, if it says okay, brain or cerebrum, that's okay. Outermost will be cerebral cortex, and inner will be medulla. Or in this case, we can say cerebral medulla. But this arrangement of cortex and medulla is also found in the brain. Likewise, now since it's found in the brain, it's okay, we'll also find this arrangement of cerebral, like our cortex and medulla, as well in the spinal cord. So if you take it's okay, a section of spinal cord, we can mean it's okay, that the outer part will be cortex, or we can say it's okay, spinal cortex, and that inner part will be it's okay, the medulla or the spinal medulla. Likewise, this very same arrangement of cortex and medulla is also found in a gland on top of your kidney, which was the adrenal gland. So when we say, yes, okay, this is the adrenal gland, for instance, outermost layer of the adrenal gland is going to be, as we say, still called cortex. But since, okay, we say, okay, the adrenal gland is going to be the adrenal cortex. And or inner is going to be the medulla. Or we can more correctly say, okay, the adrenal medulla. Did you guys get that?
Yeah.
So if we look at a kidney, we can mainly say, okay, that the outermost layers of the kidney is going to be the cortex of the kidney, or called the renal cortex. Where the inner part is going to be, okay, what we call the medulla, or the renal medulla. And or ladies and the gentlemen, if you look here, you guys can see this fellow.
Yeah.
Let's just make it a little bit bigger. Because, yes, okay, this is a kidney. And pretty much, okay, what we can say is this is going to be the cortex. And then all of this here will be the medulla. Yeah. But please keep in mind, guys, okay, yes, we have the same arrangement and, yes, okay, 3 other organs or structures as well. Okay. Adrenal gland, brain, and in the spinal cord. Okay, guys. Now when we check our 2 kidneys, and let's just now get site specific here. You have a left kidney. And we have a right kidney. Now, guys, your right kidney is okay. When we look at, okay, yes, is going to be at a slightly lower level than that of the left kidney. So the right kidney is going to, or we can say the left kidney is going to be a little bit higher than that of the right kidney. And okay, yes, an easy cheat to remember why. Just think that, okay, yes, by your right kidney is okay, that's going to be, okay, a big organ, which is the liver. That needs some room. So mainly it's okay to provide room for, it's okay, the liver. That's why the right kidney is going to be at a slightly lower level than that of the left kidney. Did you guys get that? Okay. But generally speaking, yes, okay, the extent is going to be from, we can mainly say that, okay, yes, this part here of your left kidney. Let's do it this way. It's going to be at the level of G12. What do you mean by G12? Your 12th thoracic vertebra. Okay. All the way down to L3. What was going to be L3? Fourth lumbar vertebra. Now, guys, what we pretty much okay as have here, or running here, is going to be your aorta. Okay. That's okay. That aorta, that's me. That's okay. Going to be bringing blood. Yes, okay, from the heart. We talk a bit more about that. On the right side is going to be, yes, okay, another blood vessel, which may mean, yes, okay, just more referred to as the inferior vena cava. And the inferior vena cava means, yes, okay, that's going to bring blood. Well, okay, back to the right atrium. Okay. Now, what your aorta will do as it runs by the kidneys, it will give off an artery to the left kidney. Yes, okay, we'll give off an artery to the right kidney. And these are going to be referred to as the renal artery. That's mainly going to be, yes, okay, the blood vessel that, okay, yes, will carry blood to the kidneys. Okay, but these blood vessels, yes, okay, undergoes in the kidneys, yes, okay, we'll talk about that in just a little bit. But at the other end, yes, okay, when blood needs to leave the kidney, yes, that's going to happen. Yes, okay, what we on both sides will refer to as the, okay, going this way and this way, leaving the kidney and going into the inferior vena cava via what we refer to as the renal veins. Did you guys get that? Okay, so that means, yes, okay, just be blood that, okay, yes, leave the kidney and, okay, let's get into the venous circulation, or venous part of the circulation, which in this case is going to be the renal vein, which empties into the inferior vena cava. Now, guys, if you look at the kidneys here, what is it that we can agree upon? That this and this are the lateral sides. This end here. This end here is, okay, that's the medial side of the kidney. Okay. So if you take a kidney just individually, that's fine. He says, okay, this was all right kidney, for instance. What do we have here? An area through which is okay, the renal artery enters the kidney. At this same medial side of, yes, okay, your right kidney, as we say. Is going to be the renal vein, leaving the kidney. And what we also have at this point here is also going to be as okay where our ureter will leave the kidney. And what do we call this area here on the medial side of the kidney? Where the blood vessel enters or the artery enters, the vein leaves, and the ureter leaves. This is your renal hilus. Did you guys remember your hilus from your lungs? Because what did we have then? Or okay, as we had the veins leaving, we had the arteries entering, and we can say, yes, okay. We also had the main bronchi. And what do we call this point here? Is okay, where these structures were entering or leaving the lungs. We call them the hilus. Okay. So on both sides, or on both kidneys, on the medial side was at this point through which, yes, okay, the arteries will enter, the vein will leave, and okay, yes, the structure which we in the kidneys call the ureter will be leaving as well. Mainly because, okay, whatever PP or urine was produced in the kidney is okay, will eventually is okay, exit or is okay, leave the kidneys via the ureters. Right? But on the medial side of both kidneys, whether it was the right kidney or the left kidney, do we have that point that we call the hilus. Did you guys get that? Right, okay. Or if we look at our kidney here, you guys can see this?
Yes.
Right, okay. So what do we have? Yes, okay, we have an artery entering. Okay, we will eventually, yes, okay, have a vein that leaves. And we also, yes, okay, have the ureter. So what is it that we mean is, okay, you can refer this whole image is going to be, is okay, is where right here, your renal hilus. Did that make any sense?
So I'm sorry, the renal hilus is where the blood vessel enters or leaves?
Yes, because you have an artery that will enter, you have a vein that leaves, right?
Okay, thank you.
Not only that, you missed the most important fellow here. Your ureter. Okay. Did that make sense? Did that make sense?
E- Yeah, so what's the definition of the renal hilus?
There's no definition. What do you mean? Everything doesn't have a definition.
Okay, so it's just an opening where something leaves.
No, it's not an opening. It's mainly as okay, the point at the key. Oh, maybe you can say it's okay. We talk of the kidney, whereas okay, the artery will enter, the vein will leave, and your ureter will leave.
Thank
Okay, clear. Okay. Did we have a similar structure in the kidney, in the liver? No, sorry, not liver. Lungs. Yes. Okay, but what enters in the lungs? Well, okay, you have the arteries enter, you have the vein leaving. By the lungs, yes, okay, you don't have ureters, you had a bronchi, right? No, right? Okay,
Yep.
and where was the hilus found in the liver? Oh, sorry, in the lungs, on the medial side or the mediastinal surface. Where do you find the hilus in the kidneys? On the medial side. Did that make sense?
So on the right side of the kidney, that's where the hilus is, and then the left kidney is where the hilum is. If that makes sense.
It's the same. It's the same.
Okay.
Why would you call hilum on the right and hilus on the left? Yes, Dennis. Why would you call it hilum on for the right kidney and hilus for the left?
I thought the hilus was, yeah, the hilus is on the right.
It's on both kidneys.
Oh,
It's
but when
on both kidneys. Oh my God. So yes, okay. I here just draw the right kidney, but okay, my dear, you can still say, well, okay, yes, this is your left kidney. So my dear, I said that okay, yes, the hilus is going to be as okay on the medial side of both kidneys. So the medial side of your left kidney is going to be facing right. And the medial side of the right kidney is going to be facing left.
okay.
Okay. But it's not that you call this, okay, this on the right kidney, you call this the hilus, and for the left kidney, you call it a hilum. No.
Okay.
Clear. Okay. So this is your right kidney, this is the left kidney. So it's okay. It is on the medial side of both of the kidneys that, okay, yes, where the arteries will enter, the veins will leave, and so will the ureters. So this area of both of your kidneys was what we call the hilus. Just as we had in the lungs. Okay, the point on the medial surface of both lungs, or the mediastinal surface, that was okay, that area on the mediastinal surface of the lungs, where it will receive the blood vessel, it will give out the blood vessels, and will also, okay, receive the main bronchus. That part of the lungs was called the hilus of the lungs. Okay, Justine, you had a question there?
Yes. So I know we're not talking about the respiratory system right now, but you did mention the hilum I know that's where the bronchi enters into the lung, but I didn't write in my notes on that there was an artery and vein entering. I only wrote the artery in the vein in the alveolus. Is that correct?
No. Where's the artery and vein going to come from? Their rules. They're not going to be dropping down from the blue sky. They're going to come from some bigger vessels, right?
Yeah.
Yeah, okay. Any questions? So hopefully, guys, at this point, it's okay. There should be no doubt that if we said we had a kidney, it's going to receive an artery. That was just called a renal artery. Renal is just okay pertaining to kidney. Artery will be as okay the blood vessel that brings blood to the organ here. The organ here is a kidney. At the other end, would there be a vein leaving the kidney? That's called a renal vein. Okay. And what the kidney mainly is going to be doing. This is going to be the main factory where the urine is produced. And we don't want that urine to accumulate in the kidney. And what was the point? That has to leave the kidney through its own tubular system or through its own tube passage. And that passage is what we call the ureter. And that is also going to leave each kidney on the medial surface from an area of the kidney that is called the hilus. But whether it's the right kidney is the hilus is going to be on the right medial side of the kidney. Okay. Or whether it was the left kidney. The hilus is going to be on the medial side because that's going to be where the renal artery will enter. The renal vein will leave. And so it's well, the ureter. Did you guys get that?
I'm sorry, can you repeat that one more time?
What?
You said it will enter from somewhere and leave from another.
A renal artery will enter the kidney. A renal vein will leave the kidney. From that medial notch called the hilus, from which the ureters also will leave. Mainly as why do we have the ureters? Mainly as to transport the urine that has been produced in the kidneys.
Thank you.
Have any of you ever seen a kidney bean?
Yes.
Good. Or you want me to bring one from my kitchen? Have you seen kidney beans in the pod? Good. Now you see the kidney beans in a pod. Do you see a small, that's okay, structure by which, yes, okay, the kidney is attached to the pod? That point where the kidney is attached to the pod is going to be the hilus of the kidney bean. That's going to be, as okay, the feeding channel through which, as okay, it receives, as okay, the nutrients when it breaks, as okay, starts as a small kidney bean like this and grows. Okay. Now, guys, each kidney has approximately 1 million structures known as nephrons. Okay, now what is that the nephron is going to be? We can mean it's okay, that's going to be, it's okay, each of those individual filtering systems that produce urine. Okay, so there's approximately, as okay, 1 million of these individual filtering station in each kidney that we call a nephron. Okay, and each of these is okay are individually is okay going to be doing what? Is okay filtering. Okay, what is that they're going to be filtering? Filtering the blood. Mainly is okay to extract the waste products that was carried by the blood. Okay, extract that so that it can actually okay be excreted from the kidney into the ureters, from the ureters to the bladder, from the bladder urethra. Okay, but these are going to be as okay the filtering stations, yes, okay, where the urine is being produced. So you can mean it says okay, the kidney was a factory, and in that factory, it's okay, we had 2 factories. There was 1 million employees. And each of these employees mainly as okay just had the job of producing urine. Clear? Okay. Now we just going to just okay look at the structure of a nephron. And for that, guys, I will write you guys just okay pay attention to 2 diagrams in your book. Yeah, okay. Figures 16.5 and 16.4. But let's see. Okay, guys, look here. if we say is okay, we had a kidney. Now what we know is that there's going to be a artery coming in to the kidney. We call that the renal artery. Is that clear? Okay. Now what this renal artery is going to do is, okay, once it enters the kidney is going to just, okay, branch into a lot of smaller arteries that will be called the renal arteriole. At the other end, what we will have is we're going to yes, okay, the main vein that will leave the kidney, that's going to be yes, okay, the renal vein. Okay, but that renal vein is mainly as okay going to be formed by as okay a lot of smaller veins that will be that we will call the renal venules. Okay. Now, guys, generally as okay in circulation of most organs, what we mainly would had was there would have been an artery. That artery was going to give off smaller branches, which we'll call arterioles. Those arterioles would give off smaller branches, which we call capillaries. Where we mainly say it's okay that these capillaries here at the other end is okay will unite to form venules, which will unite to form what we call a vein. Did you guys get that? Did you guys get that, or should I finish the session?
So the capillaries come together to form the venules, and the venules
Exactly.
come together to form the vein.
Exactly. Now, guys, please keep in mind, this is for all other organs in your body. Okay, so for instance, okay, we take the example of the lungs. The blood vessels that we had around the alveolus or alveoli or capillaries. Okay. Did that make sense? Right, okay. So this is going to be as okay the arrangement for all other organs in the body, except from the kidney and the pituitary. But okay, let's keep that aside from now. Because okay, what your kidneys is going to do is it's going to have not just one, but it's going to have two sets of capillaries. Or we can say is okay, your nephron is going to have not just one, but two sets of capillaries. So in the kidneys, we can mainly say, okay, our thing is going to be like, we can say, okay, artery divides into smaller branches called arterioles. which is going to just, okay, divide into smaller structures called capillaries. But before these capillaries actually become venules and become veins, there's going to be, okay, another set of capillaries. And then these capillaries, okay, will unite to form a venule, which just means okay, small veins, which will unite to form the vein. Did you guys get that?
Yeah.
Now, guys, what is going to be okay, the function of the capillaries? Okay. Now, usually, guys, when I say that substances are being delivered to cells by blood, whether that was oxygen, whether that was one thing or another thing or another thing, or even as, okay, things such as nutrients and so and so. Okay. That delivery of those substances, okay, to the cells was going to happen at the level of capillaries. Likewise, okay, yes, when cells were just, okay, going to deliver things or substances from the cell to the blood, that exchange between the cells and the blood was going to happen at the levels of capillaries. Did you guys get that?
Is that general, like for all the
For all,
organs?
for all.
Everywhere? Okay.
Yeah, okay. Okay. So it's only going to be as okay at the level of capillaries, where we have capillaries, that there's going to be as okay exchange between blood and what's outside the blood. And between us, okay, what's outside the blood to the blood. Did that make sense? Okay. So for instance, okay, just recently as okay, we talked about the alveoli. Those blood vessels in the alveoli are going to be capillaries. Clear? Okay. Just like, yes, okay, when we talked about, yes, okay, absorption of nutrients from the gut into the villi. Now, the blood vessels that we have running in the villi were capillaries. And that's why it's okay that they were able to, it's okay, that the substance is okay, that was absorbed from the villi or from the gut through the villi into the bloodstream, was able to make it to the bloodstream because that's okay, the blood vessels that we had were capillaries. Did you guys get that? But one thing that's going to be a little bit unique about the kidney, or let's say it's okay, the nephron, is that okay, it's not going to have just one set of capillaries, but a whole two sets of capillaries. Did you guys get that?
Yeah.
Good. So we said, okay, artery became arteriole. We can say, okay, will become, these are the first set of capillaries of our nephron. Okay, and that first set of capillaries in the nephron is actually, it's okay, what we'll call the glomerulus. Then we will have, okay, yes, a second set of capillaries. In nephron, which is going to be, okay, what we call the tubular capillaries. Okay. Okay, guys, let's try to look here. Okay. So what we mean, you can say that, okay, yes, in all this, this is an nephron. Okay. All this here is going to be your nephron. Now let's just follow the blood. Because, okay, this, okay, came from the aorta. We had the renal artery. Your renal artery is, okay, divides into, is, okay, what we can call arteriole. Now, this arteriole here is going to be called afferent arteriole. Now you remember the word afferent from your lymphatic system. The reason that we call this one here the afferent arteriole, because that's going to just, okay, bring it to the first capillary bed, which is this fellow here. This is mainly, is, okay, your first capillary bed, over which is, okay, called the glomerulus. So this is going to be the first point at which, is, okay, the blood is going to be filtered off from its waste products. Clear? Okay. Now, had this been any other structure after, yes, okay, the bed of capillaries, we may, yes, okay, just had a venule that would then have become a vein and, okay, left. But ladies and the gentlemen, since there we have, okay, as not just one bed of capillaries, but another bed of capillaries as well, this is going to be, as, okay, your efferent arteriole. So this is still an arteriole. But the reason that we call it efferent is just, okay, just that we remember, yes, okay, if we says, okay, we had a lymph node, that was a blood vessel that was going to bring, that was a lymphatic vessel that was going to bring lymph to the lymph node, that was what we call the efferent. That was going to be, okay, lymphatic vessel that carried away from the lymph node, we call that the efferent. Okay, so both these, is, okay, are still going to be arteriole. The reason we call this one an arteriole as well, because there's still another system of capillaries that needs to get its blood. Okay, but before going to this, oh, it's okay. Before going to this, okay, what happened afterwards? Okay, we can. It's okay. Let's try to see. It's okay. What happens here? And what we call it's okay the glomerulus. Okay. Now, guys, there are different ways in which it's okay we can divide the structures of the nephron. Let's do it this way. So if we say it's okay, nephron. Okay. We can say it's okay, that means it's okay, maybe it's okay. Two major components of the nephron. We can say it's okay, that's going to, let's say it's okay, being the vascular. Now when we say vascular, that's going to, it's okay, be related to the blood vessels. And pretty much okay, as to some extent parallel to that is going to be as okay another system of the nephron, which we mean is okay, just can say it's okay, the tubular system. Now guys, when we look at the vascular part, we can say it's okay, what did we have? We can say it's okay, we started a renal artery. Renal artery become renal arteriole. Now we can say it's okay, this first renal arteriole here is okay, is going to be an afferent arteriole. With then yes, okay, just leads to yes, okay, what we call the glomerulus. Okay, and we can mean say okay that this glomerulus here is okay, what was that? That was okay as a set of capillaries, which just is going to lead off into yes, okay, what we'll call, sorry, the efferent arteriole. Which then will lead on to yes, okay, what we'll call the peritubular capillaries. Which then will become the renal venules, and then become yes, okay, the renal veins. Is that clear? Okay. Now, guys, our tubular system of the nephron. Okay, pretty much okay. As if we talk of the nephron, the vascular part of the nephron, it's made as okay. There's going to be this part here, which will be as okay of your nephron. The tubular system of your nephron, guys, is okay. Mainly, it's okay. Starts by your glomerulus. So the first component of the tubular system of the nephron is going to be as okay what we call the Bowman's capsule. Did you guys get that? Now the Bowman's capsule is going to lead into yes, okay, what we call the proximal convoluted tubule. Which means, yes, okay, then will lead into, yes, okay, a structure that we call the loop of Henle. Yeah, your loop of Henle, yes, okay. The reason that we call it a loop is mainly, yes, okay, because it has a limb that go down and a limb that goes up. So it's going to have, yes, okay, a descending limb of the loop of Henle and an ascending limb of the loop of Henle. After your loop of Henle, what do we have? We're going to, now we have a proximal, then there's going to be, okay, something that we call the distal convoluted tubule. And that is mean as, okay, going to lead into, as, okay, what we call the collecting duct.
Sorry, what does that say? Descending what?
Descending limb, LIMB,
Okay, thank you.
ascending limb. Because, okay, guys, now when we look at the diagram, you'll see, it's okay, that we have the structure of your nephron that we, as a whole, yes, okay, we'll call the loop of Henle. But it's okay, what does it have? It means, okay, starts with a descending limb that's going to go down, and then there's going to be, as okay, a limb of the loop of Henle is going to be ascending or going up. So we had a descending limb, and we had an ascending limb of the loop of Henle. Okay. Now we can mainly say that, okay, yes, what we in the nephron refer to as the peritubular capillaries. Where do we find those? They are mainly, as okay, going to be around your proximal convoluted tubules, the distal convoluting tubules, and extensively, yes, okay, around, yes, okay, your loop of Henle. That's where we find, yes, okay, this second set of capillaries called the peritubular capillaries. Because what is that the proximal convoluting tubule is? Is this a tube? What is a distal convoluting tubule? Is going to be a tube. What is going to be as okay your loop of Henle? It's made as okay, just going to be a tube. And around these tubes is going to be as okay, where we have the second set of capillaries referred to as the peritubular capillaries. Did you guys get that? Okay, so each nephron, mainly as okay, whatever they produce is going to be as okay, given off into as okay, what we call a collecting tubule. Okay, so any questions? Okay, so what we mainly said was okay, yes, that okay, starts at the glomerulus, the filtering of the blood that was running in the blood vessels happens to start, it's getting filtered at the glomerulus, which was okay as the first network of capillaries. Okay. But before we get to that, let's just do it this way and say that the glomerulus along with the Bowman's capsule is going to be referred to as the renal corpuscle. Okay, so what do we have? We say as okay, we had this extensive network of capillaries. Okay, where did that come from? Yes, okay, we come is okay, it came from what was going to be as okay, the efferent arteriole. At the other end, okay, the blood was going to leave it, was going to do so is okay via the efferent arteriole. Okay, now just think of it in this way, guys. What is it that the blood is going to be bringing or carrying?
Nutrients.
That's going to, yes, Maria?
Nutrients and oxygen and stuff.
Okay. No, I don't think that the kidneys will be needing nutrients. Okay, they may be needing oxygen to just okay be able to work. But they carry blood, right? And what did we have in blood? Okay, there was going to be nutrients, there was going to be protein, there was going to be sugars, there was going to be you guys forgot all about blood?
Plasma?
Okay, good. So what do we have in plasma?
Water.
Okay, that was water. Okay, good. Anything else that we find in plasma?
The plasma proteins?
Plasma proteins.
Okay, good.
Hormones?
Okay.
Hemoglobin?
Nope.
No.
No, we don't have hemoglobin in plasma over here.
Oh, I was thinking blood.
Okay.
Salts, minerals, electrolytes.
Okay.
Fibrinogen? Fibrinogen?
Okay.
Waste. Because
There you
plasma
go.
transports waste.
At last, the magical word, waste. Because what was it that the kidneys were there to do?
Getting rid of wastes in your body.
Get rid of the waste. And how are they going to be able to do that if they don't receive it? Clear? Okay. So yes, okay, what that blood carries, well, okay, our main focus is mainly going to be as okay. Your main says okay. Finally, is okay, talk about plasma and waste. Not just the all or not all of the plasma, primarily is okay. The water from the plasma. Okay. And what did I said that the capillary or the glomerulus was? It was capillaries. What would that mean? That actually is okay. Here, things such as water, which was okay, coming from the plasma, and pretty much okay, all the wastes that your blood wants to, as okay, get rid of is going to, as okay, leave the bloodstream through the capillaries, and actually, as okay, is going to be collected into this structure here that we call the Bowman's capsule. Yeah, okay. Now, guys, please keep in mind that, okay. But besides that, it's not only going to be as okay the plasma, or let's say it's okay the water from the plasma, that eventually is okay, may become a part of, yes, okay, what we pee out as urine. And the waste products that the blood mainly is okay wanted to get rid of in the first place to become, yes, okay, a part of urine. That may even, yes, okay, be different. We can say it's okay, salts that also, yes, okay, may exit here. There may even, yes, okay, be sugars or glucose and so on, so on. So that may, yes, okay, exit here. Okay. Did that make sense? Okay. Now, ideally, it's okay. We never want to see proteins in the urine in the first place. Okay. Okay. First of all, it's okay. The reason that okay, normally it's okay, proteins won't be able to, it's okay, exit the capillaries or leave the bloodstream is because, it's okay, proteins are very large molecules. So they're too big to be able to normally, yes, okay, leave the bloodstream. Okay. But what you may hear is okay when we talk about kidneys and so on, so is that there's going to be as okay what we can call glomerulonephritis or glomerular filtration diseases and sorts of conditions, okay, which may cause that okay, there may be defects in the glomerulus which are big enough to let proteins leave the bloodstream and okay, yes, enter into the yes, okay, be collected in yes, okay, what we call it, a Bowman's capsule. Okay, but what we mainly can say is whatever leaves the glomerulus, which okay, as primarily as okay, should be as okay, the water from the plasma. Most of the waste products that okay, as the blood wants to get rid of, because this was metabolic waste. Your body doesn't need it anymore. Clear? Okay. Even as okay, we had some salts leaving the glomerulus. Even if it's okay, we found things such as sugars, etc., etc. When we say salts, we can even say salts and minerals. We can even say alcohol, yes, okay, electrolytes, and so on. So, but the substance that primarily as okay leaves the glomerulus and gets collected in what we call the Bowman's capsule. This substance here is going to be as okay what we'll call a filtrate. Or as a matter of fact, yes, okay, we can call it the glomerular filtrate. Did you guys get that?
It's
Okay.
called glomerulus filtrate.
How many?
It's called the glomerulus filtrate.
Glomerular filtrate. Or we can even, as okay, just call it a filtrate. That's fine enough there. Okay. Now just look here. Okay. So we can say it's okay. This was your glomerulus. Okay. And okay, as what we mean is okay, how around the glomerulus is going to be as okay, what we can call is okay, the Bowman's capsule. Now I'm not going to take you guys down to is okay, this diagram here. Okay. Because what is it that this is going to be? Now we can mainly say, okay, this was the afferent arteriole. Let's just choose another color. Which means, okay, I was going to bring blood to this glomerulus. So this here is, okay, this is your glomerulus. Okay. And we can mainly say, okay, as blood runs through, yes, okay, these capillaries here, what is going to happen? Substance that was brought via the blood through the afferent arteriole that enters into, yes, okay, the glomerulus is going to, yes, okay, start to be filtered out of the glomerulus. Did that make sense? Pretty much, okay, yes. Okay. And whatever substance, yes, okay, leaves the glomerulus, which mainly is okay, it's going to be, okay, yes, water. Most of the water, most of it, most likely as okay, will be peed out as urine. Okay. Along with this water, yes, okay, is mainly as okay, going to be as okay, the waste materials that we will gather. Okay. Okay. But there's still going to be as okay, some salts, we can say some minerals, some yes, okay, electrolytes, even as okay, things as okay, some sugars, which normally as okay, wouldn't be peed out. Unless okay, somebody is severely diabetic. Okay. Okay. And really, and that's only as okay, only if the, for instance, okay, was big defects, structural, yes, okay, defects in the glomerulus. There were actually, yes, okay, 2 pores, then only then, yes, okay, is it that we will have proteins being filtered out. But whatever is filtered out, and mainly, yes, okay, as you can see here, is okay, is going to be collected in this structure here, which I mainly, as okay, said was going to be the first structure of your tubular system of the nephron, was what we call as okay, the Bowman's capsule. Did that make sense? Okay. And after which, yes, okay, whatever. Okay, so this substance, yes, okay, that was filtered out from the glomerulus, we could call it filtrate, or we can call it glomerular filtrate. Okay, and what is that going to be made up of? Primary water, wastes, some salts, minerals, electrolytes, even, yes, okay, some sugars, and only yes, okay, if there is damage to the yes, okay, glomerular structure. It is porous enough to let big molecules like proteins be able to, yes, okay, pass through, yes, okay, the glomerulus into the, okay, Bowman's capsule. So what the Bowman's capsule means is going to be the first part of your tubular component of the nephron. So whatever is collected there is going to be what we still won't call this urine, but it's going to be referred to as the filtrate. Did you guys get that?
So just to confirm that I'm understanding this correctly, the substances enter through the afferent artery and gets filtered and into the
Why substances,
Bowman's-
my dear? What? Okay, Asma.
or the
Why
waste,
substance?
sorry. The
No,
waste.
why substances? What's going to be flowing in the afferent arteriole is going to be blood. It's a blood vessel. It's going to carry blood. Did that make sense?
Yeah.
Okay. Okay. So what you mainly, as okay, was say was going to leave the blood stream. Or we can mean is okay, leaving it in the sense that okay, it's going to be filtered out of the blood. It's primarily going to be as okay, some water, waste products. You were the one who said that it's okay, blood or plasma carries waste.
Right.
Now is the time to get rid of that, right? Right there?
Right.
Good.
So-
Okay. Now, and okay, let me just speak out here.
Yep.
Along with this waste and water, salts, some electrolytes, even as okay, some sugars, that's okay, may leave the bloodstream at the glomerulus and become a part of what we call filtrate. Did that make sense?
Yes.
Okay. Now, whatever was not filtered out at the glomerulus is still blood. That's going to leave the glomerulus in what we'll call the efferent arteriole. Efferent with an E as an elephant. Did that make sense?
Yes.
Now, when I told you guys the lymphatic system, I said, please make sure that you remember or understand what the word afferent and efferent would mean. This is why. So when I say something, I mean it. Just like when I said the hilus, I meant it. Just as I said fundus yesterday, I mean it. And you will see it. Okay? But guys, that's okay. If you look at this structure here, the glomerulus, along with the Bowman's capsule. This is what we as okay will call a renal corpuscle. And we can mainly say, okay, this is going to be as okay with the substance that we now call filtrate. But this filtrate, it is eventually as okay, we can say, okay, still going to be as okay, further process, and eventually as okay is going to become urine. Okay? But what we mainly can say is, okay, what was and what didn't get filtered out from the blood. Most likely, yes, okay, you don't want red blood cells to, yes, okay, be able to, yes, okay, pass the glomerulus and, okay, yes, enter into the, become a part of the filtrate. Okay? Things like that, right? So that's okay, what of blood, yes, okay, didn't become a part of the filtrate, which is now, yes, okay, in the Bowman's capsule, is just going to leave the glomerulus via, is okay, the efferent arteriole. Okay, now whatever was, that's okay, collected in the Bowman's capsule. Okay, now let's just go and look at this picture here. This is for the Bowman's capsule. Your filtrate is now going to just okay pass through your tubular system of the nephron. Okay, and when we say as okay, the tubular system of the nephron, I said, well, okay, here. It started at a Bowman's capsule. Okay, so what are we going to just okay get in the Bowman's capsule? That's okay. What we just okay call the filtrate. And this filtrate is now going to just okay run through the remaining of the tubular system of your nephron, which is going to be the proximal convoluted tubule, followed by as okay the loop of Henle, followed by the distal convoluted tubule, which would end up being as okay what we call the collecting duct. And what we mainly as okay have around these three things: proximal convoluted tubule, the loop of Henle, and the convoluted tubule, or sorry, distal convoluted tubule, is going to be as okay that second set of capillaries that we call the peritubular capillaries. So let's just look here, guys. So Bowman's capsule, glomerulus. We had the afferent arteriole mainly because that brings blood to the glomerulus. At the other end, it's okay, we can say, okay, we have the arteriole that takes the blood away from the glomerulus. Blood containing, okay, all other substances which did not become a part of the filtrate because it was not filtered out at the glomerulus and collected in the glomerulus tubule. Oh, sorry, in the Bowman's capsule. So right after Bowman's capsule, yes, okay. Or if we just look at it in this way, guys. We can say glomerulus. And we can say Bowman's capsule. And what is that going to lead into? Yes, okay, the tubular system. Now, the reason that we say a tubular system, because it's going to be a tube, a tubular passage. So what left the glomerulus is going to be, okay, will become the filtrate. And that filtrate is now going to be running through the tubular system, like this. Okay. And now, yes, okay, around this tubular system is going to be, yes, okay, the next set of capillaries, which means, yes, okay, just is a continuation of, yes, okay, carrying the blood that left the glomerulus via the efferent arteriole. So the first part of our tubular system in our nephron is going to be, as okay, our proximal tubule, or proximal convoluting tubule. And guys, this fellow here, this yellow part here, that's the loop of Henle. Did you guys get that?
Yeah.
Right, okay. So what do you see? Well, okay, if this is the loop of Henle, well, okay, you have an arrow pointing down here. So that would mean that that's going to be, okay, or this is going to be the descending limb of our loop of Henle. And the reason that we call it a loop mainly is, okay, because it loops and makes a U-turn and goes up. So this part here, that's going to be the ascending limb of the loop of Henle. Did you guys get that? After which we can mainly say is, okay, as far as our tubular system goes, yes, okay, we have the distal convoluting tubule. And this distal convoluting tubule mainly is, okay, then just becomes what we call the collecting duct. Did you guys get that? Now let's just look at the vascular component, ladies and gentlemen. So what is, okay, after the glomerulus is our efferent arteriole. Mainly that's, okay, goes on. Okay. And if you see, it's okay, it forms as, okay, this network of capillaries around, yes, okay, your tubular system. Okay. And what happens? And what is it that, okay, as this tubular system here is going to just, okay, transport? What's going to be carried in this tubular system? Pretty much, okay, what at the Bowman's capsule started its journey as filtrate. Did you guys get that? Did you guys get that?
Yeah.
Okay. Now, what did I say about filtrate? It was not urine yet. Why? Because it may, yes, okay, contain a lot of substances which we probably, yes, okay, didn't want to be excreted in the urine. Right, okay? Some of those salts, minerals, electrolytes, right, okay? Even yes, okay, if there was some sugar, unless, okay, somebody is, okay, is extremely diabetic. Okay, then one way of, okay, is getting rid of a lot of the sugar is going mainly is, okay, to pee it out. And that's why we in the first place call it diabetes mellitus, because then yes, okay, the urine became sweet. Did you remember that one? Okay. Unless and until that is the case, as okay, you most likely yes, okay, you may yes, okay, want still just okay retain that sugar. Or get that sugar back. Is that clear? So that's mainly as okay what may happen at your peritubular capillaries. Or as okay in your tubular system. That substances okay that were a part of filtrate because they managed to exit the bloodstream at the glomerulus may now leave the tubular system and get re-picked up by the blood. Did you guys get that?
So is the peritubular capillaries, so that is part of the tubular system because they're picking it
Nope,
up?
nope, nope. When you say capillaries, they are blood vessels. They carry blood.
Right, but it's picking it up from the tubular system, right?
Yes.
Okay.
Right. Okay. 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 But again, yes, okay, we can say, yes, okay, this is still going to be, yes, okay, a co-transport. Okay, because there may be things that, okay, yes, still wasn't filtered out in the glomerulus, but which may still have, yes, okay, the chance of then leaving the bloodstream and, okay, yes, get picked up by the tubules. So that's okay, you can say it's okay, you have the capillaries or the peritubular capillaries, and you have the tubule. Right, okay. Now there may be substances that's okay in the blood. In your peritubular capillaries that your body may still not want, that may make its way to the tubules. Did that make sense, my dear?
Yes.
Right, okay. And likewise, okay, what was it the tubules were carrying? Yes, okay, they will carry filtrate. So there may be just, okay, things in the filtrate that your body still says, okay, well, you managed to just, okay, escape out of the bloodstream here. We don't want you to become just, okay, a part of urine because we still need you. And that's going to just, okay, get pretty much, okay, leave the tubule and actually just, okay, get reabsorbed by the blood. Things such as, okay, some salts, some minerals. You, yes, okay, sugars, etc. Clear. Okay. But what we mainly as okay can say is okay that once that transport between is okay the tubules and your peritubular system or peritubular capillaries is over. Whatever is okay mainly is okay is collected in the collecting duct is going to be as okay what you will call urine. Because after this point here is okay, there's probably not going to be any way that okay, yes, substances or yes, okay, whatever ran through the tubules is going to yes, okay, be reabsorbed by the blood. Did you guys get that? Okay. Now, don't go into all the details of okay, yes, acidic environment, cold transport of this, cold transport of that. That's too much. Okay. Did that make sense? Okay. But even as okay, at your peritubular capillaries, well, okay, capillaries, they're still blood vessels. Well, why do we call them peritubular? It's in the name. Surrounding the tubules. Did that make sense? That's why we call them peritubular. Okay. But their capillaries mainly is okay because they're still going to okay allow transport of substances from the tubules into the bloodstream or from the bloodstream in the capillaries into the tubules. Did you guys get that? Any questions? Okay, well, what's pretty much okay as leaves the distal convoluting tubule and ends up in that's okay what you will call the collecting duct. The substance that ends up in the collecting duct is going to be urine produced by each individual nephron. Now, guys, we said we had at least 1 million nephrons, or approximately 1 million nephrons in a kidney, right? Okay, which mainly means that, okay, we will have 1 million collecting ducts. So what we mainly can say is going to be the next is the collecting ducts. Because okay, there's going to be a lot of collecting ducts that is going to unite to form what we call a minor calyx. What we mean is, okay, from is okay, a lot of nephrons is a lot of collecting ducts. They will form the structure here is okay, which we call a minor calyx. What we mean you can see is that there's going to be as okay a lot of minor calyces that will unite to form as okay what we call a major calyx. If that makes sense. The major calyces pretty much okay as close to your hilus will empty into as okay what we'll call the renal pelvis. And from the renal pelvis is going to be as okay your ureter. Okay, guys. Yes, okay. We mean yes, okay. Could just smuggle in yes, okay. This renal papilla. Okay. So, guys, if you mean yes, okay, look at the entire tubular system of the kidneys. It all started as okay from the Bowman's capsule. Go into as okay what we call the proximal convoluting tubule. Goes into the loop of Henle, which goes into the distal convoluting tubule, which goes into the collecting duct. Here we can say collecting ducts become yes, okay, renal papilla. From renal papilla, do we get yes, okay, what we call the minor calyx. Minor calyces, yes, okay, will unite to form what we call a major calyx. Major calyces will unite to form as okay what we can call the renal, as okay empty into as okay what you call the renal pelvis. And from the renal pelvis is going to be as okay the ureter. Which then just will go to the bladder and urethra. So just one last picture before it's okay, we go on break. So this area of a kidney, this area. That was the renal pelvis. Any questions? Now, off the record, yes, okay, in this chapter, or you might have seen, yes, okay, similar things in the previous chapters as well. But in this chapter, yes, okay, from place to place or from page to page, you may see, yes, okay, sorry, bigger or smaller, yes, okay, red boxes of what you can call as, okay, flowcharts. Okay, if I were in your shoes, I would look at those boxes of flowcharts, because that's an easy way of, okay, as you guys say, it's like writing things in the normal sequence. Yeah. So similarly, as okay, you can make it up from as okay, your vascular part of okay, as your kidneys, renal artery, arterioles, efferent arteriole glomerulus, efferent arterioles, peritubular capillaries, renal venules, renal veins. The tubular system start at okay, Bowman's capsule, proximal convoluting tubule, loop of Henle, distal convoluting tubule, collecting duct, renal papilla, minor calyx, major calyx, renal pelvis, ureter. Now, guys, just take a break. And when we come back, we will talk a bit about okay, the two separate types of nephrons. Okay? So I see you back at, should we say, 1:05?
Thank you.
You're welcome, Deb.
I had a quick question.
Yes.
Out of curiosity, I was wondering, since our final exam got pushed back and we didn't get a lot of time to study for this test compared to the last, is it possible that this quiz can be pushed back to Monday so we have more time to
No,
study?
no. You have more than enough time yet.
Okay.
It's going to be like, and it's only 3 chapters. Okay. Okay, guys, now just a little thing about the nephrons. Okay. And we can mainly says, okay, That's just a way of classifying the nephrons. Let's put it that way. So we can mean says, okay, that we have two types of nephrons. Now one is going to be as okay, what we can call the cortical nephrons. And what cortical means is going to be as okay, pertaining to cortex. So when we say cortical nephron, that means going to be, let us say it's okay, okay. Let's define the first one. That the nephrons which are in the cortex of the kidney. Okay, so we said, okay, yes, we had a kidney. Right, okay. We already said that, okay, yes, this part of the kidney here was what we call the cortex. And we can maybe say that, okay, yes, the nephrons, please guys, okay, that we talk of the nephrons that are going to be completely located within the cortex are going to be referred to as being cortical nephrons. Okay. And without any okay exaggeration and so on. So we can mean it says okay that 90% of our nephrons are going to be cortical nephrons. Which made us okay, just brings us okay to the other kind of nephrons, which are going to be as okay what we'll call juxtamedullary nephrons. Okay. Now, what's going to be a juxtamedullary nephron? Sorry. Okay. We can mean this as okay. That's going to be as okay nephrons where okay as the major part of the nephron, or most of the nephron, yes, okay, still is going to be inside the cortex. Okay. But what these nephrons here actually will have is that we can see that the loop of Henle, you guys recall the loop of Henle? The loop of Henle of these nephrons here actually is okay. Will okay, yes, extend into the medulla. Okay, so those kind of nephrons will be referred to as the juxtamedullary nephrons. Okay, so we can mean it says, okay, these will be the nephrons. Now we can say it's okay. Most of them, or most of their part, is in the cortex. But the loop of Henle of these nephrons extends into the medulla. Did you guys get that? Okay. So those will be, that's okay, what we call the juxtamedullary nephrons. Otherwise, it's okay. Physically, it's okay. Your nephrons, mostly it's okay, will be found in the cortex. Okay. Okay. And as I said, it is from the nephrons that, okay, yes, we have, okay, it's collecting ducts. Become, yes, okay. Renal papillae became, yes, okay, minor calyces, become major calyces, and empties in the pelvis. And from there, yes, okay, leaves the ureter. Did you guys get that? So the difference between a cortical nephron and a juxtamedullary nephron is that the juxtamedullary nephrons have, because it's okay, longer loops of Henle, because it's okay, they leave the cortex and actually it's okay, extends into the medulla. Does anybody have any questions about that? Nope. Okay. So these were our two kidneys. And what remains said, okay, yes. What we leave in the kidneys was what we call the ureters. And what is that the ureters are going to be? We can roughly say it's okay, the main is okay, just a continuation of the tubular component of, yes, okay, your nephron. All we can say is going to be, yes, okay, a tube that carry the urine. And this urine is okay, what was it? That's okay. Produced in the kidneys by the nephrons. Okay. To the urinary bladder. Now, approximately, as okay, in an adult person, these ureters are approximately as okay, 10 inches long. But their main job is mainly as okay, just to transport the urine from the kidneys to the urinary bladder. Which mainly as okay, just brings us to this last structure, or this structure here. That we now we're calling the urinary bladder. Now the urinary bladder, first of all, is okay, it's going to be a hollow structure. Okay. And here's okay, guys. I'm just going to make a lateral view of the urinary bladder. So it's going to be hollow, which mainly means that okay, it's on the inside, it's okay, it's going to be empty. Why would it need to be empty? Mainly so it's okay that it can get filled up by the urine. Okay. Now where that urine going to come from? That is going to come from the ureters. Now, if this, for instance, okay, was a side view or a lateral view of the urinary bladder, what you actually will see is okay, is that during its last course, the ureter actually is okay, runs posterior to the urinary bladder. Is that clear? Okay. So if this is an anterior view and we say, okay, this is okay, the hollow space of your urinary bladder. We can mainly say that, okay. Look at it in this way. That is, this was the ureter. This was the ureter. Here means okay, runs posterior to the urinary bladder. And eventually will open up into the urinary bladder. Did that make sense? Okay. By running posterior to the urinary bladder and okay, yes, eventually open up into the urinary bladder. Now, guys, the wall of your urinary bladder is going to be as okay, loaded by muscles. Okay, guys. Now, classification wise, that's okay. We can say it's okay. Let's put this way. That the wall of the urinary bladder is loaded by muscles. Now, may I just ask a dumb question? What kind of muscle do you think this muscle is going to be?
Smooth.
Huh?
Smooth muscle.
Smooth muscle, exactly. Very good. Okay. So there should be no question about it that this is going to be a smooth muscle. Okay. But help me, Lord. This smooth muscle of your urinary bladder actually is okay, has a name. And we call it the detrusor muscle. Okay. Did you guys get that? So the smooth muscle which we found, sorry, that we find in the wall of the urinary bladder is known as the detrusor muscle. Did you guys get that? Now, another thing about your urinary bladder. Now, guys, we can say, okay, it will be here. Or, yes, okay, if we look at it in this view, well, okay, this is actually going to be, yes, okay, an inside view of the bladder, looking at the posterior wall of the bladder. It's going to be, yes, okay, this triangular area. And this triangular area mainly is going to be referred to as the trigone. You can make it as, okay, trigone as, okay, one sheet is, okay, that's a triangular area. Okay. Or if you mean it's okay, just magnify this as, okay, take a closer look at this trigone here. Okay. Or if you mainly find that, okay, yes, it's at this upper end and at this upper end here of the trigone, yes, okay, where the ureter enters the bladder. Is that clear? Okay. Now some of you, okay, now we can mainly says, okay, what is going to be the use of this trigone here? Now this is mainly as, okay, going to be we can say it's, okay, a sensory area of the bladder. The mainly as, okay, will get stimulated by urine. Or mainly as, okay, sense that there is urine in the bladder. Clear? Okay. Did you guys get that? So that's okay. Functionally, what is it that the trigone is? It's mainly as, okay, a sensory area in the urinary bladder. Which means, yes, okay, it's going, we can say, okay, it gets stimulated, or yes, okay, it gets triggered by, yes, okay, the presence of urine. Okay. Anatomically speaking, yes, okay, what could be, yes, okay, the importance of this region here? That it mainly, yes, okay, is marking the entry point of the right and left ureter into the urinary bladder. Any questions?
I have one.
Yes.
So the bladder is loaded with smooth muscle, which is involuntary, but wouldn't that mean we'd be peeing our pants all the time?
Nope. Be coming to that why that's not the case.
Okay.
Okay. Did you get that? Okay, guys. Now another thing. We say, okay, this was the bladder. We can say, okay, this is the bladder just after we had peed. Okay. Now, what is that we know that, okay, as the bladder may, as okay, have the ability to is to distend. Pretty much, okay, as more, okay, there's no, but that's going to just, okay, be more and more and more and more and more, and more and more and more and more and more and more. Urine, that's going to just, okay, end up in the bladder. Okay. But, if you look at the bladder, we can mainly say that, okay, yes, the inner wall of the bladder is going to be thrown into, yes, okay, these folds. And what do we call these folds? Seen on the inner boundary on the inner wall of your bladder. Rugae. And where else did we have rugae?
Stomach.
Stomach. So when we talked about the stomach, did I tell you that please remember the term rugae? Because it's going to be repeated in another system, in another structure. So if I said so, I meant so. Because, and when I mean something, yes, okay, that's because it's going to happen. So here we are. Okay, yes, okay, you can say, yes, okay, and copy and paste concept thing, right? Okay. Okay. Just like, okay, as you just filled your stomach with food, it will need, yes, okay, that room to be able to, yes, okay, have the capacity to be able to expand without its wall ripping apart. So that was why SOK was thrown into these rules that mean SOK will enable it to expand without rupturing. The same for the bladder. Right, okay? Because the bladder mainly SOK will need to SOK be able to expand, mainly because SOK continuously, more or less SOK is going to SOK be receiving urine. Did you guys get that? Okay. So these folds, yes, okay, are mainly, yes, okay, also going to be referred to as rugae or rugae. Any questions? Okay. Now, guys, structure-wise, let's just, because let's say that, okay, yes, the bladder is now fully distended. Okay. Now, okay. Now, maybe, but mainly as okay will happen, yes, okay, once we see, there's approximately, yes, okay, about 300 cc's of urine in the bladder. That may be as okay the point where we mainly can say that okay that trigone areas okay may start to initiate what you can call as okay a urinary reflex, which means okay will cause these detrusor muscles in the bladder to okay slightly start to contract. Okay. But they mainly says okay that the bladder still will be able to okay on an average okay store up to 800 cc's. 800 milliliters of urine before it's okay being fully filled. But which means that's okay, well, let's call it okay, these contractions of the detrusor muscles are going to be even stronger. And now, yes, okay, pretty much okay, pushing the urine and try to just okay, push it out. As a result of what we can call yes, okay, urinary reflex. Now earlier, yes, okay, somebody asked me that how is it that we don't pee in our pants? Now guys, the last passes through which is okay, urine is going to pass through is going to be the urethra. Okay. Now we will talk a bit about is okay, the anatomical differences between this in the male versus female in just a little bit. But no matter is okay what it is, this fellow here is okay is again just like your anal canal. It's going to be equipped with two sphincters. One is going to be yes, okay, what we'll call the internal urethral sphincter. And we can mainly say that, okay, this one here is okay, is going to be made up of smooth muscles, which we already know, yes, okay, is going to be involuntary. Okay, but you can mainly say, okay, that, okay, once this pressure here is okay, by the contraction of the bladder as okay, as a result of a urinary reflex, gets too much, it's going to, it's okay, push, and okay, the urine and this sphincter here is okay, will relax. Now, had it not been us being equipped with a second sphincter, yes, we will have peed in our pants. And that's why it's okay, we have a second sphincter mechanism, which is going to be the external urethral sphincter. Which is going to be made up of skeletal muscles, which makes them voluntary. So even though it's okay, the internal is okay, urethral sphincter has relaxed or succumbed under the pressure by the urine being pushed due to the contraction of your detrusor muscles in the bladder wall. This one will still be contracted and say, okay, right now it's not socially acceptable for me to pee. Did that make sense?
I'm sorry, what is it? External what?
Urethral sphincter.
Thank you.
Just have you had an internal urethral sphincter, then you have an external urethral sphincter. Okay, and what did we mean by a sphincter? Mainly, it's okay, there's this valve mechanism which is mainly made up of muscles that will circle around. But when they constrict, block the passage. When they relax, that's okay. Open the passage. So ideally speaking, unless somebody is okay, what you can call it, okay, urinary incontinent. Okay. That's okay. External urethral sphincter will remain closed until it's okay, this person pee. Okay, now I can pee. It may happen that even is okay with all his or her might and strength. It's okay that it's okay. This may is okay succumb underneath the pressure. And okay, yes. But let's not talk about that. So for remaining, I says, okay, as a result of a urinary reflex. Right? Meaning that's okay, will lead to, yes, okay, what we can call, yes, okay, opening of these sphincters here. And eventually, it's okay, lead to, yes, okay, peeing, or we can say it's okay, passing the urine. Now, some people may call this urination. Or as okay, a more official term of urination. Or the process of peeing is going to be as okay, what we call micturition. So now pretty much okay, it says BP. It's okay, passing from the bladder through the urethra. Okay. And guys, the urethra is okay, that was the last passage. Or it's okay, we can say the last area or structure of your urinary system. Now, when we talk about, yes, okay, the urethra and males versus females. Now, guys, in males, sorry, the urethra is going to be long, whereas females have a relatively short urethra. So, if you find this, okay, take a female pelvis. We can say it's okay, rectum, anal canal, things like that, anus. Then we can say it's okay. We have okay as the bladder with a short urethra. And in this case, it's okay. Maybe it's okay between the urethra and it's okay the anal canal. It's going to be considered okay the vaginal opening, vagina, and on top of that it's going to be as okay the uterus. Now, contrast to this guy is okay if we look at a male pelvis. Of course, okay, he is going to be shooting too, so that's going to be as okay an anus. We can still say it's okay that he or she, no, he, sorry, yeah, it's okay, has a bladder. But through which it's okay, there's going to be a longer urethra. Now, in the male, just okay, there's an organ. Pretty much okay as at the base of your bladder. And male is okay surrounding the first part of the urethra. And that gland is going to be as okay what we call the prostate gland. So we can mainly say okay that the part of the urethra that runs through the prostate is going to be as okay the prostatic urethra. Okay. Then there's going to be as okay a part of the urethra here. That means okay, it's going to be called the membranous urethra. After which guy is okay, the remaining of the urethra of this fellow here, sorry, is going to be as okay, be running through the penis. And what we actually is okay, we'll see as we talk about the reproductive system. Is that okay? As in the penis, there's actually going to be as okay 3 muscular bodies, or 3 is okay structures made of the are made up of, yes, okay, muscles called the corpus cavernosum. But that's going to cause, this is going to be the cavernous urethra. Pretty much, okay, the part of the urethra that runs through the penis is going to be, okay, the cavernous urethra. Yeah, okay. So that's pretty much why it's okay. It is going to be longer than that of the female, because in the male, it's okay, it has to run through the penis as well. Did you guys get that? Okay. Now, another thing, and we can see as okay, mainly as okay, negative effect of okay as the short urethra in women. That's mainly as okay one of the major reasons that okay as women are more likely to yes okay suffer from UTIs. Okay. Primary is okay. The reason is because of the short urethra. Now, guys, just when we talk UTIs, like me says, okay, the first area of just okay developing a UTI most commonly is okay is the bladder. So that's what we call cystitis. Okay. But what we may see in yes okay UTIs, because it's okay the UTI mean yes okay just stands for urinary tract infection. But the thing that I want you is okay bring to your attention here is the word tract. Because okay, what's going to be part of your tract? The urethra, your bladder, even yes okay the ureters, and yes okay even yes okay the kidneys. But what we have in okay as far as okay UTIs are concerned, we may say okay the UTIs has an ascending affinity. What would that mean? That people may start off with a infection of the bladder or bladder infection, which is okay as common areas of UTIs to develop. But what do they have? This ability of ascending. So it can actually is okay go from the bladder through the ureters or ureters. On the ureters to the kidneys. Is that clear? Okay. But please keep in mind, guys, okay, that is a possibility. That's why we says, okay, it has this ability to yes, okay, ascend up from urethra to bladder, from bladder to yes, okay, ureters, from ureters to kidneys. But that doesn't exclude the fact that there's okay, there are yes, okay, there is possibilities that okay, yes, people may develop infections in the kidneys itself. Okay. where this would just be referred to as upper UTIs. And anything is okay below that is going to be as okay lower UTIs. Did you guys get that? So that's okay. We can say that in the urinary tract infections can ascend from bladder to kidneys. Did you guys get that? Whereas sorry, not that I want to bring in another system while talking here, but that's okay since we are at it. We can see that, okay, yes. Respiratory tract infections can descend. Now just think of it. Usually it's okay, how do you develop a urinary tract, respiratory tract infection? It starts with a runny nose. I may start with, okay, a throat infection. Clear. But it's okay, a bad running nose can actually, it's okay, go back to the throat. From the throat, airways. And from airways, all the way, it's okay, to the lungs. So what happens? It starts up here and it goes down. Did that make sense? Okay. But with that said, there are still going to be as okay germs out there as okay, which primarily as okay just will target the lower airways or lower respiratory tract. Where did the lower respiratory tract start? From the trachea and down. Anything above there was the upper respiratory tract. So it's not only for structuring, yes, okay, but also as okay, because it's okay based on the types of bacteria that may target, yes, okay, different parts of the tracts. Whether it was the respiratory tracts, a part of the respiratory tract, or that of the urinary tracts. So if sometime it's okay, you go and talk about it, okay, say, well, okay, I think I have a UTI. And the doctor, he or she, now I may say punch, it's not going to be a Michael Tyson punch, okay? Not that kind of punching. But that's okay, me, that's okay, just slightly, it's okay, punch you by, it's okay, where your kidneys are. Why would he or she do so? Because it's okay, if it was an infection in your kidneys, that would hurt. Okay. Whereas, okay, if it was an infection in the bladder, it's okay, it will hurt more. It's okay if he or she is okay. Palpate in the areas, okay, where your bladder is. Any questions, guys? Yes.
The kidney papilla, what did you say the function was for that?
Don't worry about that.
Oh,
I didn't mention anything about the function. Just remember his name. That's it. It's made as okay. I guess it's like a little body of fat in the kidneys. Clear, okay? A small fatty body in the kidneys. And usually it's okay whenever you see it's okay fat, it means okay, it can be for two functions. Cushion or energy storage. Okay. But guys, if I was in your shoes, okay, what you see, especially that's okay in this chapter here, there's a lot of those small red boxes. I will look at those. Okay. But I pretty much, okay, yes, I think I laid it out pretty well. Here. Your tubular system, for instance. Bowman's capsule, proximal convoluted tubule, loop of Henle, distal convoluted tubule, collecting duct. Collecting duct says, okay, we'll meet a renal papillae. Okay, from renal papillae, that's okay, we will have a lot of minor calyces. A lot of minor calyces, yes, okay, will join to form what we call the major calyces. Major calyces mainly opens up into, yes, okay, the area right next to your hilus inside the kidney, which is going to be called the renal pelvis. And from the renal pelvis is going to be, yes, okay, that the ureter will actually, yes, okay, lead and carry blood to the bladder, and from there, it's okay to pull the urethra. Okay, so you can mean that, okay, this is going to be, okay, the flow of what might have started journey as a filtrate here, but eventually it's okay, it becomes urine as it exits here. So these sequences here are important. That's all I can say. Yes, guys. Everybody still there? If you are there, turn on your cameras. If not, you'll be marked absent. Oops. A lot of people, it's okay up here. What's the point of having your cameras off?
Because I look crazy.
Yeah, be
That's
serious.
fine. It's not like we're having, okay, as a Miss or Mr. Junior, it's okay, USA contest. Okay. Is that your Superman outfit or what?
Excuse me, look adorable.
Okay, dear.
Susan, we
Okay.
can't hear you. Your mic is off.
I'm sorry.
Okay, guys. I guess this is all that I can offer for the urinary system. Okay. So we can make this as okay. Primarily as okay, mostly as okay, the what you want to call it? It's okay, the anatomy or the anatomical structures and so on. So okay. Now tomorrow is going to, okay, we don't need to dig.